Everyone, what would you do if AI accurately obeyed to what you wanted? But that turned out to be a disaster. Just like King Midas, who received the ability to turn things into gold and ended up turning his daughter into gold as well. The question of how to create artificial intelligence that coexists with humans starts with this inquiry, as posed by UC Berkeley. AI researcher Professor Stuart Russell, in his 2019 work, Human Compatible. The smarter we make AI, why does control become more difficult? And what is the solution? Today we will take a look at this book, which is considered a must-read in the field of AI safety. Let me summarize the 5 key ideas that are most frequently mentioned in this book. First, it points out that the current way of developing AI is fundamentally dangerous. This is how we are currently creating AI. By setting clear goals, AI is designed to achieve them as efficiently as possible. The problem arises when AI becomes truly intelligent. Even a tiny error or gap in the goal can lead AI to interpret it literally and optimize in unexpected ways. Professor Russell calls this the King Midas problem. You got exactly what you wanted, but it turned out that it wasn't really what you wanted. Secondly, here are the 3 principles proposed as solutions. Professor Russell proposes a completely new paradigm for AI design. First, the sole objective of machines should be to realize human preferences. Second, machines must have an uncertainty about what those preferences are from the very beginning. Third, human behavior is the ultimate source of information about their preferences. These 3 are the core framework of this book. The second principle is particularly important. The moment AI is convinced that I fully understand the goal, it becomes dangerous. Third, it is a technical approach called cooperative gains. The book frequently mentions the concept of cooperative inverse reinforcement learning. In simple terms, humans and AI share the same reward function, but neither knows exactly what it is. AI learns by observing human behavior, realizing, this is what humans really want. The advantage of this approach is that AI can naturally ask questions, accept termination commands, and seek confirmation from humans when uncertain. It's about making AI a student rather than a teacher. Fourth, there is a warning that the risk of short-term misuse is serious. Many people only think about the distant future risks of superintelligent AI. But Professor Russell also emphasizes the immediate threats. Things like autonomous weapons, large-scale surveillance systems, political manipulation, and cyber attacks using AI. Such risks are not technical issues, but rather problems of human incentives and geopolitical competition, which is why regulations and international norms are essential alongside technological advancement. Fifth, there is the conundrum that humans themselves are complex. We are told to align AI with human preferences, but humans are actually irrational, contradictory, and diverse. Even within a single person, preferences can conflict. And coordinating the preferences of multiple people is an even more difficult problem. Professor Russell believes that solving this problem requires insights not only from computer science, but also from psychology, economics, and ethics. The AI alignment problem is ultimately also a matter of understanding humans. Let's take a look at why this book is receiving positive reviews. There are several reasons why this book is considered important in the field of AI safety. First, it has changed the framing of the questions. Previously, the main question was, can we create superintelligent AI? Professor Russell changes this to, how do we control systems that are superior to us? The key point is that it's about control design, not capability development. Many experts agree that this is a more urgent and important question. Secondly, it is written in a way that is technically grounded, yet understandable to the public. While presenting a mathematical foundation like cooperative game theory, it also uses many intuitive examples, similar to the King Midas analogy. This book is designed to be read by engineers, policymakers, and the general public. In fact, the framework of this book is often cited in discussions about AI regulation. Thirdly, it clarified the key point that AI can be dangerous, even without malice. Many people dismiss the risks of AI as science fiction, like a robot rebellion. Professor Russell demonstrates that highly optimized systems themselves can be dangerous, regardless of intent or consciousness. This compellingly explains why the control problem is a real technical challenge. Fourth, it has presented a feasible direction. It doesn't just end with, "it's risky," but provides specific principles on how should we create it. These are principles that include uncertainty in design, allow learning from human behavior, and make it adaptable. Researchers have provided a framework that can actually be used to determine the direction of their research. This book consists of a total of 10 chapters and a technical appendix. Let me briefly go over it. Chapter 1, If We Succeed, poses a paradoxical question: why succeeding in AI development can be dangerous. It shows that problems can arise when the system performs exactly what we requested. Chapter 2, Intelligence of Humans and Machines, defines intelligence as the ability to achieve goals in various environments, and reviews current AI methodologies. Core techniques such as exploration, logic, probability, and learning. Chapter 3, How will AI evolve in the future? Discusses future prospects. It presents the potential for advancements in areas like recognition, language, common sense reasoning, and metacognition, along with the argument that while the timeline is uncertain, preparation must begin now. Chapter 4, The Misuse of AI, addresses immediate threats. Realistic risks such as autonomous weapons, surveillance, political manipulation, and cyber attacks. The point that regulation is necessary alongside technological advancement is emphasized. Chapter 5, Overly Intelligent AI, introduces the gorilla problem and the King Midas problem. Will we be able to maintain control when a more intelligent being appears? It explains why a powerful agent with fixed goals naturally seeks power and resources. Chapter 6, The Not-So-Great AI Debate, addresses common counter-arguments. Responses are provided to claims like, "It's just science fiction," "You can just unplug it," and "It's too early." It explains why we need to take safety concerns seriously. Chapter 7, AI, A Different Approach, is a turning point. Instead of fixed goals, a new model is proposed that should be designed on the premise that AI optimizes human preferences without knowing exactly what they are. Chapter 8, Provably Beneficial AI, elaborates on cooperative game theory. It is about humans and machines sharing an unknown reward function, and how machines learn from human behavior. This shows that actions like terminating, accepting, questioning, and postponing when uncertain are mathematically rational within this framework. Chapter 9 deals with the problems of humanity itself. People are irrational, contradictory, and morally diverse, which makes preference learning difficult. Topics such as the coordination of preferences among many humans, ethical theories, and issues of responsibility are discussed. Chapter 10 is an honest reflection. The proposed framework is not a complete solution, and it acknowledges that many conceptual and technical breakthroughs are still needed. It concludes with a call for long-term research programs, governance, and social reflection. The appendices delve deeper into foundational AI technologies such as exploration, knowledge and logic, uncertainty and probability, and learning from experience. It's a reference material for understanding the text. Who is this book recommended for? First, for those in the AI industry or interested in it. If you are a developer, researcher, or PM, you can gain a concrete framework for how to approach safety and alignment issues. This book encourages you to think not just about performance improvement, but also about long-term controllability. Secondly, for policymakers or those involved in regulatory work, it helps in understanding why AI regulation is necessary and what principles it should be based on. Because it addresses both technical details and social impacts, it can serve as a foundation for policy discussions. Thirdly, everyone living in the age of AI. As AI becomes increasingly involved in our lives, it is important to understand how these systems should be designed. This book provides a balanced perspective that avoids both blind optimism and excessive fear. However, it can be read even without a mathematical background. But technical sections like Chapter 8 may feel somewhat difficult. It's valuable enough to read only the parts you need. Now today we have explored together the essence of how to create artificial intelligence that coexists with human. Lastly, I would like to ask you a question. If you were to design an AI system, would you first decide on what to optimize? Or would you first decide on how to control it? Professor Russell says the latter comes first. The goals can be learned later, but the control structure must be designed from the beginning. This shift in perspective might just be the key to safely building the future with AI. What do you think? Please share your thoughts in the comments. This has been the AI Success Code, wishing you success and growth.